In this discussion video, we'll do an example where L'Hopital's rule breaks down. So this is problem 23 from worksheet 10, which says the limit as x approaches infinity of 3x plus sine x all over 2x. So I want to give you 2 minutes first just to try this with L'Hopital's rule and see what you notice in terms of what happens. 4, 3, 2, 1, pause it and try it for 2 minutes with L'Hopital's rule. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 2 minutes with L'Hopital's rule. So I first want to notice that if we were to sort of plug into this, on the denominator, we definitely get infinity. On the top, the 3x goes to infinity. The sine x, well, technically the limit as x goes to infinity of sine x does not exist, but it can be shown that when you sort of put it together with the 3x will sort of dominate the growth, and it'll make the whole thing go to infinity. So you can show this. This can be shown. It takes a little bit of work, but you can show this. It has the form infinity over infinity. So with L'Hopital's rule, all right, with LH, what we'll get is we'll get the limit as x goes to infinity. The derivative of the top will be 3 plus cosine x. The derivative on the bottom is 2. And with this, well, we know the limit as x goes to infinity of cosine x, well, that limit is d and e, because the cosine graph keeps oscillating up and down and up and down, and as x goes to infinity, the y values don't approach anything. Okay, so that the cosine part individually will be a d and e. So it's like you have 3 plus something that keeps bouncing back and forth between 1 and -1 and 1 and -1, all divided by 2. And that's going to make this whole thing be a d and e. So therefore, the limit as x goes to infinity of 3 plus cosine x over 2, this whole thing is going to be d and e. So that's very different from what's happening in the original limit. In the original limit, even though sine x is bouncing back and forth between 1 and -1 and everywhere in between, the 3x is getting huge. So it's like, oh, okay, you know, even when you add something that's between 1 and -1 to me, which is, and I'm huge, I'm still going to make you huge. So the 3x is like, I don't worry about the sine x so much. I'm going to make my whole numerator going to be really, really big. All right, so as a result, we can't use LH when the resulting limit, the limit that we get after we take the derivative of the top and the bottom, is d and e. And we actually see this in L'Hopital's rule itself. At the end of it, it's part of the technical language. It says, okay, the limit equals this limit of the derivatives of the top and the bottom, like this, if this new limit exists or is plus or minus infinity. But in our example here, once we got the new limit, this was the step where we did LH, L'Hopital's rule. After we did that, this new limit didn't exist, and it wasn't plus or minus infinity. It was just straight up d and e. So I can't use L'Hopital's rule. All right. So I want to end by just giving an idea. It'll be just a hint. I'm not going to work it out completely. A hint for the correct solution. Because I still think this would be a great practice problem to try. I just don't want to give the entire thing away. Okay, and the hint is we need a way to handle that sine x. As I said earlier, yeah, the whole thing has the form infinity over infinity. I said it can be shown, but we didn't show it. So my hint is sine is always between -1 and 1. Does this remind us of something that we've done before a lot earlier in our class back when we talked about limits? That's what I'm going to end the video by saying. The rest I'm going to leave for you. So this would be a great practice problem. I would absolutely try this.